In this mini lecture, I'm going to talk about exponential functions. An exponential function is just a function where the variable is in the exponent. So we have something like y equals b to the x. We use the b to stand for the idea of the base. So b is the base, x is the exponent. And so if I have a function like that, that's an exponential function. There are some requirements for this number b, the base. It has to be greater than 0, so I can't have a negative base. And for some technical reasons, we don't want b to be equal to 1. One of the reasons, if I let b equal 1, I'd have 1 to the x, and 1 to any power is just 1. So that would really just be y equals 1, which is a horizontal line. And that's just not going to have the same characteristics as these other exponential functions we're going to look at. So that's why we don't allow b to be equal to 1. So we can graph this function f of x equals 2 to the x, and I can just do it the old-fashioned way. I can just plug in some values for x and see what I get. So if I plug in 3, we get 2 to the third power. Of course, 2 times 2 times 2 is 8. If I plug in 2, I get 2 to the second power. 2 times 2 is 4. If I plug in 1, 2 to the first power is 2. If I plug in 0, remember anything to the 0 power is 1. And for these others then, we have negative exponents, 2 to the negative 1. Remember, a negative exponent means we have to take the reciprocal. So this is just going to be 1 over 2 to the 1, or 1/2. And if I have 2 to the negative 2, then that's 1 over 2 to the second power, which would be 1/4. And 2 to the negative 3 would be 1 over 2 to the third power. 2 times 2 times 2 is 8. And so if I plot these points, I go over 3 on the x and up 8. 5, 6, 7, 8, that's all the way up here. If I go over 2 and up 4, that would be there. Then over 1 and up 2. I think that's a 0.12. Next then here I've got 0, 1. And then as I keep going down the table, next I have negative 1, 1/2. So a half, we'll just have to sort of estimate that up a half of the way between 0 and 1. Negative 2 is 1/4. That's half of that distance. And negative 3, 1/8. That's practically on the x-axis. So I'd have these points, and we can sort of imagine, connecting these with a nice smooth curve. There's some philosophical stuff whether I can really do that or not. We might talk about that more in a college algebra class. So that's a curve, and then what happens is I keep going to the right or to the left. Well, if I keep going to the right, then my x-coordinates are going to have to get bigger than 3, right? I'd get x equals 4, x equals 5, x equals 6. And we see from this pattern the y-coordinate's just doubling every time, so it's just going to keep going up faster and faster. So it's going to keep going up. Now, it never goes up vertically. Eventually I could go over 10. But if I go over to 10, which would be over here somewhere, I'd have to go up 1,000. 2 to the 10th power is 1,024. So it just skyrockets on up. And if I keep going to the left, well, my x values are going to get more and more negative. So I'm going to get fractions where the denominator is going to get bigger and bigger. Well, if the numerator stays 1 and the denominator gets bigger and bigger, well, the whole fraction is approaching 0. Again, if I went all the way over to negative 10, it would be 1 over 1,024. So it doesn't ever drop down below the x-axis, but it sort of levels off. In fact, we can say that this x-axis is a horizontal asymptote, like we had asymptotes with hyperbolas. And so that's a line that graph approaches but never actually touches. And so we'd have that sort of graph. Now, this next one, I've got f of x equals 1/2 to the x. So instead of 2 to the x, it's 1/2 to the x. So I'm going to do the same sort of thing. I would get 1/2 to the third power. Well, that's going to be 1/2 times 1/2 times 1/2. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And then 1/2 squared, a half times a half will be 1/4. If I have a half to the first power, well, anything to the first power is just itself. Anything to the 0 power is 1. And then if I have 1/2 to the -1, well, that's going to be 1 over 1/2 to the 1, which is going to be 1 over 1/2. Well, that's 1 divided by 1/2, which would be 1 times the reciprocal 2 over 1, which will just be 2. And of course then I say, oh, well, probably just, 1 over 1/2, that's the reciprocal of 1/2, that's just 2. So here then, if I do 1/2 to the -2, that would be 1 over 1/2 squared, which would be 1 over 1/4. That would just be 4. And similarly then, for -3, I would get 1/2 cubed, which is 1/8, and then there's the reciprocal of 1/8 is just 8. So those numbers are familiar. They're really the same numbers we had before. The difference is now 3/1/8 is almost down here, 2/1/4 is up a little, 1/1/2 is about there, 0/1 we've got there. We've got -1, 2, -2, 4, and -3, 8. And so we get this nice curve through these points here. It's going to keep going up to the left, and it's going to come along the x-axis, and so again that would be my asymptote going across there. So let's sort of look at these two graphs together and see some characteristics. So I've just, here's the 2 to the x that we did first. That was going through 0, 1, 1, 2, 2, 4, 3, 8. And then this red graph is 1/2 to the x. So we've got some properties here. Remember, the domain of a function is the set of all the inputs, the set of all the x coordinates. And this blue graph, if I look at the x coordinates, well, the blue graph goes forever to the left, and it also goes forever to the right. So on the x-axis, it would go all the way to the left and all the way to the right. So that's -infinity to infinity. Notice the red graph is the same, right? The red graph goes forever to the left. This would keep moving to the left, even though it goes up very quickly, and forever to the right. So both these graphs have domains -infinity to infinity. The range, on the other hand, is how far the graph goes up and down. So that's where it is along the y-coordinate. Notice that here at y equals -1, if I go over to the left or right of -1, I never hit the graph. Neither of these graphs have a point on them that has a y-coordinate of -1. There's y-coordinates of +1, there's y-coordinates of 2, there's certainly y-coordinates of 4, but there's no y-coordinate of -1. In fact, there's not even a y-coordinate of 0, right? It never actually hits the x-axis, which is where the y-coordinate would be 0. I do have all the y-coordinates greater than 0. So for the range, we say the range is from 0 to infinity. So these exponential graphs will always have this type of shape. They'll go forever from left to right, but they're always going to stay above the x-axis. Now, the graph will always go through these points. What happens if I plug 0 in? Well, I get 1/2 to the 0 or 2 to the 0. Anything to the 0 power is 1. So both these graphs go through this point here, 0, 1, right? Both graphs go through that point. What about if I plug 1 in for x? Well, then I get 1/2 to the 1, that's just 1/2. 2 to the 1 is just 2. In general here, if I talk about this b to the x, b to the 0 is 1. That's what we have for the first point. If I put 1 in for x, well, I get b to the 1, which is just going to be b. So whatever the base is, the graph goes through a point with an x-coordinate of 1 and a y-coordinate that's the base. So for this blue graph, if I put in 1, the base of the blue graph is 2, so that's the point 1, 2. The same as 2 to the x. On the other hand, if I come here at that point, that coordinate is 1, 1/2. And again, because this function here has a base 1/2 to the x. So the blue graph goes through 0, 1 and then 1, 2. It's going up from left to right. The red graph goes through 0, 1 but then has to go through 1, 1/2. So it's going down from left to right. So that's what this says over here next. If b is greater than 1, right? If my base is greater than 1, like 2, then the graph is increasing. Whereas if the base is between 0 and 1, like 1/2, that's between 0 and 1, the graph is decreasing. And then the graph of the function has a horizontal asymptote with the equation y equals 0. That's that x-axis. So if I know these properties, that can allow me to graph a function like this pretty easily. The key things in making the graph is really part 2 and part 4 here. Okay, we know that it's going to go through these 2 points, and we know it's going to have this horizontal asymptote. So here, if I plug in 0, for x, I get 1 out for y. And if I plug 1 in for x, I get 4 out for y. Right? If I plug 0 in for x, 4 to the 0 is 1. If I plug 1 in for x, 4 to the 1 is 4. So this has to go through those 2 points, the point 0, 1 and the point 1, 4. And it's going to have this x-axis as a horizontal asymptote. So it has to go through those points and have that sort of curve, so it's going to have to do something like that. It's going up more quickly than 2 to the x did. But that would be my graph. Y equals 4 to the x, or I've called it k of x. The function k of x equals 4 to the x. Now, we can take this basic exponential function and sort of soup it up a little bit. So b to the x would be a plain exponential function. If we start putting some numbers with the x or after the whole thing, this h and this k, these values of h and k are going to shift the graph vertically and or horizontally. And we're going to look at how that works here. So for this one, 2 to the x minus 3, what I notice is that, my key points, if I just had 2 to the x, it would go through the point 0, 1, and it would go through the point 1, 2. Here, if I have 2 to the x minus 3, that minus 3 comes after. So if I plug in the 0, well, I would get 2 to the 0 minus 3. That would be 1 minus 3, which is negative 2. And if I plug in 1, 2 to the 1 minus 3, that'll be 2 minus 3, which would be negative 1. So I go through the point 0, negative 2, and I go through the point 1, negative 1. Now, if I had graphed the original function 2 to the x, that would have gone through these 2 points. But we don't have that point. What's happened instead, we don't have that function, right? This point 0, 1 went down 3. This point 1, 2 went down 3. Remember, this original function then would have had this x-axis as a horizontal asymptote, but it's going to have to go down 3 here. So my horizontal asymptote isn't going to be the x-axis now. It's going to be this equation, y, this line, y equals negative 3. So that the function I really want then is going to look like that, right? So that blue function is the graph that I would really want there. If I come down here, again, if we just had 2 to the x, it would go through 0, 1, and it would go through 1, 2. But that's not going to happen here because I have 2 to the x plus 1. So if I plug in 0, 2 to the 0 plus 1 is 1 plus 1, or 2. And if I plug in 1, 2 to the 1 plus 1 will be 2 plus 1, or 3. So my original graph would have went through 0, 1 and 1, 2, and it would sort of have that kind of shape. But what I have instead, I have 0, 2, it went up 1, and 1, 3, it went up 1. And so the same thing's going to happen, but my horizontal asymptote now goes from the x-axis, it goes up 1 unit. Y equals 1, that's my horizontal asymptote. And my graph is going to be like that. So it's been shifted up 1 unit. So here, this graph went down 3 units because of the minus 3. This graph went up 1 unit because of the plus 1. So what we can say is if I have f of x equals b to the x plus k, that's just the same as f of x equals just b to the x, except it's been shifted up k units if k is greater than 0, and down k units if k is less than 0. Right? Here, we've got that my k is negative 3, so that goes down 3. Here my k is positive 1, so that goes up 1. So that can help us when we see that kind of situation. So what about this here? I've got a different base, 3, that's fine. But now this minus 3 isn't down below, it's up in the exponent. So it turns out that's not going to affect the up or down, it's going to affect this graph going left or right. So again, if I think of the basic function, 3 to the x, would go through 0, 1 and 1, 3. We have to be a little careful with this one, because what I sort of want to think is what made this point nice is the fact I had 3 to the 0 power, and anything to the 0 power is 1. So I want to take here, I want to take 3 to the 0 power. But what would I have to put in for x to make this exponent 0? Right? What would I have to put in for x so that when I take x minus 3 I get 0? Well, I think it would have to be 3. Right? If I put in 3 for x, then I get 3 to the 3 minus 3. That would be 3 to the 0, which is 1. So instead of this graph here starting at 0, 1 and then going to 1, 3, here I would have 3, 1 because I have to put 3 in to get 0 out. Here then, what would I have to put in for x to get a 1? Well, I'd have to let x be 4. So then I get 3 to the 4 minus 3, which would be 3 to the 1, which would just be 3. So my original graph would have gone through the point 0, 1 and then 1, 3, and would have had this x-axis as my asymptote. What we're getting instead, we've got the point 3, 1, and the 0.43, and I'm still going to get the x-axis as my asymptote. The whole graph has just actually moved to the right 3 units. So my graph is going to look like this. And then down here, the same sort of thing. If I wanted 3 to the x, well, my key points would be 0, 1, and 1, 3. But if I have 3 to the x plus 1, my question is, to get this 0, what would I have to put in for x? Well, since it's x plus 1, I would have to put in the opposite, negative 1. So then I get 3 to the negative 1 plus 1, which would be 3 to the 0, which would just be 1. And to get this x coordinate of 1, well, I'd have to let x be 0. Because then I get 3 to the 0 plus 1, which would be 3 to the 1, or 3. So the original graph 3 to the x would have went through this point 0, 1 and 1, 3, and, you know, sort of gone up like that. Instead, we have the point negative 1, 1 and 0, 3. So it's been moved over to the left. Right? This graph, we moved 3 to the right. This graph moved 1 to the left. And that's the opposite. We would think subtracting x would go to the left and adding x would go to the right, but with this horizontal shift, it's actually the opposite. So if I have b to the x plus h, it's really the same as b to the x. But if h is greater than 0, x plus, then that's positive, it moves to the left. And if it's negative, I got a typo here, h is less than 0. And also, of course, to note, a vertical shift changes the horizontal asymptote while a horizontal shift will not. Right? These ones back here, right, when I moved up or down, this horizontal asymptote had to change. But if I move left or right, it doesn't change, right? My horizontal asymptote stays at the x-axis. So that's just a basic introduction to how these exponential functions work and how they're graphed.